Okay, so you want to buy an AI data center. Find a building, fill it with servers, charge companies to use them, watch the money roll in. Here's the strange part. Right now, Amazon, Microsoft, and Google are so desperate for data center space that they're signing 15-year leases before concrete is even poured. The demand is unlike anything the commercial real estate industry has ever seen, and yet some of the smartest infrastructure operators in the country are hemorrhaging cash so badly that a single idle building costs them nearly $5 million a day. By the end of this video, you'll know exactly what it costs to build one of these things, why power is now worth more than the building itself, how the money flows from Microsoft to your bank account, and why being in the hottest sector on the planet still isn't enough to guarantee you survive. Let's start with the price list, because this is where most people's assumptions collapse immediately. The smallest entry point is a standard enterprise facility. 20 megawatts of capacity, around 50,000 square feet. About $200 million to build. The one McDonald's version of this world. Quiet, functional, profitable if you do it right. The next tier is wholesale hyperscale, 100 megawatts, purpose-built for a single large tenant. Construction right now runs between $1 and $2.2 billion, according to Turner & Townsend's 2025 cost index. That's before a single server walks through the door. Then there's the AI-optimized version of that same building. Same 100 megawatts, but instead of standard cloud racks, you're running dense GPU clusters, liquid cooling systems, and specialized power infrastructure. Cost jumps to over $2 billion for the shell alone. $20 million per megawatt versus $11 million for a standard build. The building looks identical from the outside. The infrastructure underneath it is an entirely different machine. And then there's the category that makes serious operators go quiet. The AI campus. The Stargate project, announced in January 2025 as a joint venture between OpenAI, SoftBank, and Oracle, is budgeted at $500 billion over 4 years. Texas alone is already building 10 of these simultaneously, with 10 more planned. At full build-out, these campuses cost $45 to $55 billion per gigawatt. The number is so large it barely registers as real. We're going deep on the 100-megawatt wholesale facility. 1.6 to 2 billion to build, big enough to matter, small enough that an individual operator could theoretically own one. Now, how do you actually get into this? Because this isn't like buying a warehouse. There are invisible walls everywhere. The first wall is land. Northern Virginia, the world's largest data center market at roughly 4,000 megawatts of installed capacity, now has premium land trading above $4 million per acre. Phoenix and Dallas are cheaper but moving fast. Budget 15 to 20% of total project cost just on land before a shovel touches the ground. The second wall is power. A 100-megawatt facility needs utility-grade power connection. In Virginia, Dominion Energy has a years-long interconnection queue. In November 2025, Virginia's State Corporation Commission approved a new electricity rate class specifically for data centers using over 25 megawatts, taking effect January 2027. Getting permission to draw the power you need can take 2 to 4 years. Developers who didn't start that process in 2022 are still waiting. The third wall is equipment. Transformers now carry 2 to 3 year lead times from major manufacturers because every data center project on Earth hit the supply chain simultaneously. Construction costs hit $987 per square foot by late 2025, up 50% in a single year, driven almost entirely by electrical equipment scarcity. Here's what it costs to run this thing once you own it. Electricity never stops. At 80% utilization, a 100-megawatt facility spends $40 to $60 million a year just on power at current US industrial rates. And that number is climbing because of your own industry. US average electricity prices hit 19 cents per kilowatt hour by end of 2025, up 27% from 2019. In Virginia specifically, prices have increased 267% over 5 years. You are partly paying for your own competition's expansion. Cooling, staffing, physical security, and compliance round out the rest. A well-run facility needs 40 to 60 full-time technical staff, with salaries averaging well over 6 figures. Insurance on a $2 billion building with irreplaceable infrastructure runs 2 to 4% of asset value annually, which is $40 to $80 million. Total cost to exist before a single megawatt of revenue, $100 to $130 million per year, every year, whether your tenants show up or not. Here's how you actually make money. You are not running AI. You are a landlord who sells power by the kilowatt. The contract is called a colocation agreement. The tenant pays for space, power, and cooling. You provide the building and infrastructure. They bring the servers, you hand them an outlet, they hand you a monthly check. Right now in 2026, rates for large AI deployments average around $184 per kilowatt per month for mid-sized requirements, per CBRE's first half 2025 data. For deals over 10 megawatts, rates rose 19% in 2025 alone. It's the first real seller's market this industry has seen in over a decade. Your 100-megawatt building at 80% utilization, 80,000 kilowatts at $184 per month. That's $14.7 million monthly. Call it $175 million in annual gross revenue. The contract structure that's driving this market is the long-term commitment. In December 2025, White Fiber signed a 10-year 40-megawatt colocation agreement with Nscale for $865 million in total contract value. That's an SEC-filed number. Locked revenue, known counterparty, decade-long duration. For an infrastructure owner, that is as close to a government bond as private real estate gets. At the top of this industry sits Equinix, the largest publicly traded co-location company on Earth, with $9.2 billion in 2025 revenue and a 49% EBITDA margin. They booked $474 million in new annualized contracts in Q4 2025 alone, 60% of which were directly tied to AI workloads. That's the business working correctly at scale. Your math: $175 million revenue, $115 million operating costs, roughly $60 million operating profit before debt. You spent $2 billion to build it. Unlevered payback is over 30 years. Almost nobody builds these with equity alone, which is exactly where the danger lives. Here's how smart people lose money in this business, and they lose it the same way, different decade. In 2023, Cyxtera Technologies ran 60 data centers across 30 markets with $746 million in annual revenue. They filed Chapter 11 bankruptcy in June of that year. The reason wasn't the business, revenue was growing. The reason was over $1 billion in variable rate debt. When the Fed raised rates aggressively through 2022 and 2023, Cyxtera's annual interest expense doubled from $35 million to nearly $76 million in under 18 months. With only $40 million left in available cash by March 2023, there was no margin for error. The building was fine. The capital structure killed it. Mistake 2. Building the wrong product for the moment. Standard enterprise data centers run 5 to 10 kilowatts per rack. An AI GPU cluster needs 50 to 100 kilowatts per rack. Operators who locked into long-term standard infrastructure leases in 2019 found themselves holding assets that the market didn't want at any price by 2023. You cannot retrofit a standard facility into an AI facility without gutting the building from the inside. The construction cost is nearly the same as starting over. Mistake 3 is geography. Singapore put a moratorium on new data center builds entirely due to power constraints. The Netherlands hit grid capacity limits in Amsterdam. Ireland now consumes 22% of its national electricity through data centers. At some point, the host jurisdiction says stop, and your approved but unbuilt facility becomes a stranded asset with carrying costs and no revenue. This isn't one operator's bad luck, it's the same constraint in different zip codes. The external risk that breaks the math overnight is regulation. Export controls on NVIDIA's most advanced AI chips have already restricted who American operators can serve internationally. The Biden administration's January 2025 tiered export control framework capped advanced chip shipments to certain countries. For an operator whose tenant base includes international AI companies, the customer list is suddenly a compliance problem that didn't exist when you signed the lease. Then there's political blowback from the power grid. PJM, the grid operator covering Virginia through Illinois, estimated that data centers created a $9.3 billion price increase in the 2025-2026 capacity market. A January 2026 survey found nearly 3/4 of Virginia voters blame data centers for rising electricity bills. That translates into regulatory momentum. The only question is timing and severity. 2 scenarios, real numbers. Scenario 1. Everything works. You build a 100-megawatt AI facility in Texas. Total cost $1.8 billion. You sign a 12-year lease with a large AI infrastructure company at $190 per kilowatt per month for 70 megawatts. Gross revenue $159 million annually. Operating costs $110 million. Operating profit $49 million. With $1 billion in debt at 5%, debt service is $50 million. Net cash, essentially zero for the first several years while utilization builds. The upside if you hold, a building worth 2 to 3 times construction cost at year 10 because supply never caught demand. Scenario 2. One thing goes wrong. Your primary tenant is a well-funded AI startup. They lose their next funding round in a tighter market. They cancel the lease under an early termination clause, paying 12 months of base rent. That's roughly $13 million in penalties against an operating cost base of a $110 million term per year. You're now running a mostly empty building, spending $9 million a month, releasing into a market where 6 other operators are doing the same thing simultaneously. The difference between these 2 scenarios is a single tenant's balance sheet. That's it. The core trade. The revenue is locked if you get the tenant. The tenant is never truly locked. Here's who actually wins in this industry long term. Not the operators who build the most, the ones who own the power in the right market before anyone else needs it. Equinix didn't become a $90 billion company by building the best buildings. They built in every major interconnection hub on Earth before the AI cycle started, secured power contracts before the queue backed up, and when hyperscalers needed capacity in 2023, 2024, and 2025, Equinix had the only buildings in the right zip codes with power already connected. Their 2026 revenue guidance is $10.1 to $10.2 billion at 51% EBITDA margins. The company makes more in a single quarter than most data center operators will ever see. The moat in this business is not the building, it's the permitted, energized megawatt in a constrained geography. Once you have it, everyone comes to you. Before you have it, you are in a queue behind people who started planning 5 years ago. So if you're thinking about buying a data center right now, in May 2026, here's the only thing worth knowing. The demand is real. The margins at scale are real. The barriers to entry are also real, and they are not financial. They are physical: power, permits, transformers, interconnection queues. The money part of this business turns out to be the easy part. The hard part is getting a utility to pick up the phone. The AI revolution runs on electricity, and electricity, it turns out, is still a 4-year conversation with a regional grid operator.